work, that'd be great. If not, just follow along. So this was the last little bit I needed to teach you on the number of solutions that are possible. Okay? All right, solve the following system of equations graphically. So there was a little bit of a hiccup there because Elaine, your mic is on. I don't know if you see that. Okay. Sorry, Elaine, I muted you. I hope that seemed to be a glitch. What I'm gonna do, I just with a quiz correction. So yeah, there was a bit of a hiccup with the graph itself. It wasn't supposed to be the numbers weren't supposed to be that big, and so I apologize for that. But moving forward, if that were to happen, especially because I didn't give you a grid, you just have to allow. Maybe I will just show you this graph. Okay, I will just show you the answer to this. So basically, if you chose to rewrite it, which I saw a lot of you do, and if you did that correctly, you would have earned two out of 3 marks right there already, because that's a significant amount of work. And then if you didn't have a point of intersection on your graph, but the lines were graphed correctly, I would just take off half a mark for that missing. And I used a scale of 2 units, so every mark represents 2. I changed it. Instead of going up by 1, I went up by 2. And then I graphed it, and so it looks a little different, but it ends up being negative 16, 16. And so when you plug it in and you verify it, so if you, because you didn't have a point of intersection, a lot of you couldn't do the verification, so you lost half for that and half for this. And some of you did verify and you realize it's not adding up. You should have then at least stated that there is no solution, right? Or something like that to be consistent. So what I will do is I'll make this part out of 2, making the whole quiz out of 13. So whatever your mark was, when you got it back, it's still out of 14 on the quiz, but when I enter it, it'll be out of 13, so it kind of makes up for that. So the graph, I thought I would just leave it there. Some of you use the grids that I gave you, great. Just next time, just change the scale to 2, right? And so if you label your X and Y axis, just maybe label every other one, and then I will know from that. So we'll leave that part as is. You need to just rewrite it, right? If possible, like rewrite it. It's a lot better and safer to do so. And then number 2, I asked you to use substitution method. And so when there are fractions, like you can keep them, but I would strongly suggest get rid of fractions. You multiply by the lowest common multiple of all the denominators. So in this case, you take the first one, and there it's 2, right? In this case, you just multiply that by 2, and watch that you get y first minus x is equal to 10. So some of you forgot to multiply that constant by 2 also, so this is what you get, right? And this one here, you would I would multiply by 4 because that's the only denominator, so you get 4x plus 3y is equal to 4 times 4 is 16, okay? And now it's really, so this is 1 and 2, this would be equation 3 and 4, right? So now you can work with these, but if you were to verify, remember this, if you verify with the originals, right, with 1 and 2. Because if you made a mistake, it will be apparent when you plug in that it's not working out. If you made a mistake going from 1 to 3, for example, then you will find out now, okay? Now you pick one of them and isolate, because substitution means you want to isolate and then plug that into the other one. I choose to isolate the first one. And you go y is equal to x comes over plus 10. A lot of you did, I actually enjoy watching different ways of solving it as long as you're consistent. And yeah, right, some of you multiplied by different values and you came up with all sorts of creative ways of doing that. And that's fine, okay? So you have y here. I would have given you 1 mark for doing this. And then you substitute this into that one, into the fourth one now. So we have 4x plus 3y, which is x plus 10, is equal to 16. Okay? You distribute, so watch for the negatives, right? If it had been negative 3, you go negative 3 times x, negative 3 times 10. Okay? In this case, it's just 3x, right, like that, and then it's 30. That is equal to 16. You combine your 3 and your 4x. The 30 comes over subtracting. Okay, that a lot of you missed that part, that it comes over subtracting. So you get 7x is equal to 14 negative, and then you divide both sides by 7, x is equal to negative 2. Okay, so you got that part. And then you take this and you substitute that into either one of them, right? So I can go y minus x, and x is negative 2, right? And that is equal to 10. So you have y plus 2 is equal to 10. Y is equal to 10 minus 2, right? So these two negatives turn into a positive, but when you bring that over, it turns negative. So it's y is equal to 8. And so the solution is negative 2, 8. Okay? You got to state your solution because you will lose marks if you don't. Okay? And keep that in mind moving forward. And I'm going to probably ask you to verify more often than not because oftentimes you'll realize that you made a mistake. Okay? So it shouldn't take you that long to do. Just plug in and make sure left side is equal to right hand side. Oh, maybe I'll show you a more compact way to verify. So if you take the first one here, right, just go like this: half times y, which is 8, right, minus half times x, which is negative 2, is equal to 5. Just plug in both the x and the y. Notice that the order is reversed, so you got to make sure you plug in the right number in the right place. This gives you 4. Negative and negative is positive, right? So this would be 1 times 2 is 2, divided by 2 is 1. 5 is equal to 5, check, right? So that's how you basically checked it with the first one, check it with the second one. It's negative 2 plus 3/4 y, and y goes in there, and that's supposed to be equal to 4. And so you have negative 2, 4 goes in here twice, goes in there once, so it's really 6 is equal to 4. So 4 is equal to 4, check. If it's not equal, you got to put a line across, right? If I ask you, is this point a solution, verify, you plug it in, and if they're not equal, you got to make sure you cross it out, okay? But this verifies that your solutions. I would strongly recommend you do it regardless if you have the time. Maybe come back later and verify to make sure you got it right. Question 3, elimination. This one was done well. This one was done fairly well. And so you either choose to try to eliminate the x's or the y's. In this case, I will go and try to eliminate the x's. So I will multiply the top by 4, be clear as to what you're doing, and I will multiply the bottom one by 5. And I will, because they have opposite signs already, I won't mess with that, okay? So that's 20x plus 8y is equal to negative 4, right? And then it's negative 20x plus 15y is equal to negative 65, okay? This cancels out. In this case, you're adding the equations, because if you add negative, right, a positive and a negative, it turns out to 0. So you end up with 23y is equal to negative 69. You divide both sides by 23. Y is equal to negative 3. There you have the first variable. If you wanted to go back and repeat the same steps, like you multiply both equations so that you can eliminate y and then solve for x, that's also acceptable. Okay, but I will plug this one in into the first one. So 5x plus 2 times negative 3 is equal to negative 1. And then you have 5x positive 2 times negative 3 is negative 6 is equal to negative 1. 5x is equal to negative 1 plus 6. Watch the signs. 5x is equal to 5. You divide both sides by 5. X is equal to 1. So the solution is 1, negative 3. Quick check here on the side. 5 times x plus 2 times y is equal to negative 1. This is 5 minus 6 is equal to negative 1. That's negative 1 is equal to negative 1. Check. Okay. And the second one is negative 4x plus 3y is equal to negative 13. This is negative 4. This is negative 9. Like that. And negative 13 is equal to negative 13. So you've done a quick check and you're good to go. And last but not least, the word problem that caused a lot of you headaches. And it's okay, but you got to learn and start thinking about it, okay? You have a coin box, contains $40 in toonies and loonies. There are 5 more toonies than loonies. Okay, that's the one that a lot of you got stuck on. So we can let T be the number of toonies, L be the number of loonies. Okay, so the first, be sure to define variables and create the linear system that was supposed to happen here. So toonies are worth $2, right? So 1T and 1L, right? That combination is $40, right? So we'll figure out, so the dollar value of it goes with the dollar value here. And then the next one, there's 5 more toonies than loonies. You could have expressed that in several different ways. You can go, if you take the toonies and subtract the loonies from that amount, you should have 5, right? If you subtract the 2, you have 5, because the number of toonies minus the number of loonies should be positive 5. The difference should be 5. Or you could say that the number of toonies, right, would be equal to loonies plus another 5, because there are 5 more toonies than loonies. So you take the number of loonies and you add 5 to it. That would be another way of doing it. Okay, so, and it's really, if you just look at it, it's the same equation, just stuff brought over and rearranged. So either one of them would have done the trick. Okay, and then so solving the system, then most of the time you will solve by substitution. Not that you have to. Okay, so that's our system, and maybe you can rewrite this one, and you go that loonies is equal to the 2t comes over and the 40 is still there, right? So I've isolated that. I'm going to substitute that into this one here. So toonies is minus L, right? So it's negative 2t plus 40 is equal to 5. I might have taken the hardest route, I know, but I want double negatives to show up and so forth, okay? So this is basically a -1 up front, so that changes the 2t positive, and it affects the 40, changes it to a negative, and that's equal to 5. This is 3t is equal to 5 plus 40. 3t is equal to 45. Divide both sides by 5. Wait a minute. By 3. Sorry. Divide both sides by 3. And that's 15 toonies. So we underline that. We plug that into either one of them. So that's 15 minus L is equal to 5. Negative L is equal to 5 minus 15. Negative L is equal to -10. Divide both sides by -1. L is equal to 10. Okay? So we'll verify. We'll go 2 times 15 plus 10, supposed to be 40. We have 30 plus 10 is equal to 40. 40 is equal to 40, so that checks out. Then we take the second equation. Toonies minus loonies is supposed to be equal to 5. 5 is equal to 5. Therefore, 15 toonies and 10 loonies is the solution. And because it's a word problem, make sure you write a little statement to finish your question, okay? Yes, there are many ways of doing it. Just make sure you show your work, okay, to do that.